Alright, in this video, we are going to discuss some problems regarding geometric sequence, and we know that the general term for geometric sequence is a sub n is equal to the first term times r raised to n minus 1. So our first problem, it says that if the sequence 2, 4, 8, 16. So here, 2, 4, 8, 16, what makes it a geometric sequence is that, by definition, in geometric sequence, the sequence progresses by multiplying a term by a constant value to get the next succeeding terms. Okay, for example, and that value is what we call r. Okay, that's what we call r. Okay. So from 2, 4, 8, 16, as you can see, the term is multiplied by 2. And so on. Therefore, our r, which is common ratio, is 2. So we have there. Okay. So since the number being multiplied is constant, therefore, this is a geometric sequence, 2, 4, 8, 16, and so on. So our concern is, what is the 15th term? What is the 15th term? Okay, so we have here solution for number 1. We have a sub 15 is the first term is 2 times r is 2, and n minus 1 means 15 minus 1 is 15. Okay, as you can see here, it's just like we are just multiplying the same bases. So it's like saying x squared times x cubed. We have x5. So it's the same here. It's 2, 1 plus 14. So that is 2 raised to 15. Okay. In most problems, usually multiple choice, they don't evaluate 2 raised to 15. Because that will become a big number. It will be a big number. You're going to evaluate 2 raised to 15. So that will be it. Or if you're going to evaluate that is 32,000. 32,768. 768. Okay, so that is RP. If we're going to continue this pattern and we go with a 15th term, that will be 32,768. Okay. So our number 2 problem is that 200, then 100, then 50, 25. That geometric sequence, if we're going to continue that, what term is 25 over 32? So this is a little bit different problem, but let's check if this is really a geometric sequence. Okay, so from 200 to 100, that's like division of 2. So division of 2. Again, by definition, in geometric sequence, r is not by division but by multiplication. Okay, so what number should we multiply by 200 to get to 100? What number should we multiply by to 100 to get 50? It's like saying 200 is divided by 2. Okay, 200 is divided by 2. It's like 200 is divided by 2. It's the same thing as saying 200 is multiplied by 1/2. Okay, so generally, how do we get r? R means r is just 100, the present term, let us say in consideration, divided by the previous term, which is 200. So you'll get 1/2. So that is why here we have times 1/2. Okay, so r is the number being multiplied by a present term to get the next term. Okay, to get r, the present term in consideration, such as 100, divided by 200, which is previous term, so you'll get 1/2. So if you're considering 50 as the present term, So that's 50 divided by the previous term, which is 100. That's still the same 1/2. Okay. So that gives us here, I'll just write it again here, 100 or 200, 150, 25, and so on. What term is 25 over 32? So it's like you're looking for n. What is n? And we know that r is just 100 divided by 200. If this first two terms is hard for you to simplify, you can go with the other two terms, okay, such as 25 and p over 50. Okay, so you have 1/2. Okay, so we know that a sub n is just a sub 1 times r raised to n minus 1. Okay, so what do we have here is that this becomes our a sub n. Okay, that becomes our a sub n. So how do we do that? So we have 25 over 32. Okay, and a sub n is 200. The a sub 1 rather is 200 times, we know r, that r is 1/2, and our problem is n minus 1. N minus 1. Oh, this is a little bit challenging. So here we have, we can eliminate 200 by simply multiplying. Let's multiply this by 1 over 200. Again, with this one as 1 over 200. So this one will be by division. This will become 1. So we are left on the other side. We are left with the right side. We have 1/2 of n minus 1. So we have here, as you can see, 25 and 200. We can simplify that further. I think I need to highlight that we can set. So this becomes 1 over, how many 25 are there in 200 is that we have, I think, 8. Yeah, 8. Okay, so this becomes 1 over 8 times 32 is what? 8 times 32 is 256. 256. Okay. Now the problem is this one. How do we deal with 1/2 n, 1/2 raised to n minus 1? What we're going to do is we're going to express this one in exponential form. Okay, with base as 1/2. Okay, with base as 1/2. So it's like saying that, the idea is, it's like saying that if x cubed is equals to 3 cubed, as you can see, therefore x is 3. If we have the same, so if we have 2 raised to x, the same as 2 raised to 7, by logic, it's just x equals 7. So that's the idea there. So we're going to express 1 over 256 as in exponential form with base 1/2. So how do you do that? For example, we have 9. We can express 9 as 3 square. The same with 1/4. You can express 1/4 as 1/2 square. Okay, 1/2 square. So the same with 1 over 8. We can express it as 1/2 cube. Okay, so this is what we call the exponential form. So again, if we have 1 over 256, we do not worry about the numerator. We are concerned with 256, express it as base 2. I think that is 2 raised to 8. So we can say that this one is 1/2 raised to 8. Okay? Because 2 raised to 8 is 256, 1 raised to 8 is 1. So I think, yes, that's 2 raised to 8, 256. So here we have, since we already expressed 1 over 256 with base 1/2. Okay, like that. Okay, so the same with this logic here, we can bring it there. Okay, therefore, since the base are equal, the exponents must be also equal. So we have 8 equals n minus 1. Okay, that gives us 9. N is 9. Okay. Okay, so what does it tell us is that n equals 9, meaning ninth term. If we are going to continue 200 divide 2, 100 divide 2, 50 divide 2, 50 divide 2 is 25, 25 divide 2 is 25 over 2. If we're going to continue that, in the ninth term, we'll get 25 over 32. So that's basically what it means. So let's have some another problems involving with this type of problems. So we have this next problem. Number 1, we have 1/2. Next is 1/4, 1/8, and 1/16. And we're going to get the 10th term. Okay. So we're going to get the 10th term. If this is the kind of problem, you just have to continue until 10th term. Then you'll get to get the 10th term. Okay. But if we're going to use the formula, is that a sub 10 gives us a sub 1 times r raised to n minus 1. Okay, our a sub 1 is basically 1/2 times our r. How do we get our r? Again, to get r, I will just consider one term, which is easy for you, divided by the previous term. Okay, I think let's take a look with 1/4 divided by 1/2. So we can say r is 1/4 divided by 1/2. That is 1/4 times 2 will get 1/2. Okay, so it's like saying how many 1/2 are there in 1/4. 1/4 divide 1/2, so that there are half. So we have here 1/2 raised to n minus 1 means 10 minus 1 will get 9. The same context a while ago, since they are the same base, we can just say that 1/2 raised to 1 plus 9. Therefore, we have 1/2 raised to 10, and that is 1 over 1024. So if we're going to continue this sequence, the 10th term will be 1 over 1024. Okay, so next is number 2. We have 2, 6, 18, 54. R is 3, because multiply 2 by 3, you'll get 6 times 3 again 18 times 3 again 54. And if we're going to continue the sequence, what term will be 13,122? What term will be 13,122? So it's like saying a sub n, a sub 1 times r n minus 1. We have our a sub n is, we are determining if what term is that, because we are concerned of n. Okay, and our a sub 1 is 2. Our first term is 2. We'll go back here. Our first term is 2. Our r is 3. Okay, our r is 3. 3 raised to, we do not know, n minus 1. So let's eliminate first. Not really eliminate, but let's get rid of this 2. I think that will be divide both sides by 2. Can do that. Therefore, we have 3n minus 1 6561. 6561. Okay, here we go again. The right side is exponential, and where the variable is the exponent itself, the n minus 1. So the way to do this is to express 6,561 into exponential form, such that the exponential form of that is base 3. Okay, so how do you do that? Let's take a look at 3 raised to 5. 3 raised to 5 is, and to do that, 3 raised to 5 is 243. That's not. So let's continue with 3 raised to 9. 3 raised to 9 is 19,683. That's too far. So let's a little bit adjust. 3 raised to 7. And, or 3 raised to 8. We'll see. Oh, 3 raised to 8. 3 raised to 8 is 6561. That's correct. So we can express this as 3 raised to 8 equals 3 raised to n minus 1. Okay. So again, the logic is that since the base are equal and this is an equation, therefore the exponent must also be equal. So we can say that that is 8 equals n minus 1. Therefore, still the same, n is 9, 9th term. Therefore, that 13,000 there, that, okay, I'll just go back there, that n equals 9, that 13,000 there is 9th term.